This video is on the quadratic formula and the discriminant. As we saw in the previous lesson, one way to solve a quadratic equation is by factoring. However, not all quadratic expressions are factorable. One method of solving a quadratic equation that always works is to use the quadratic formula. The quadratic formula is the result of solving the equation ax squared plus bx plus c equals 0 for x. The quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. The expression that's underneath the radical sign, that is b squared minus 4ac, is called the discriminant. The value of the discriminant can tell us how many real solutions the quadratic equation has. So if b squared minus 4ac is greater than 0, that is, if the number underneath the radical sign is positive, then the equation has two real solutions, and the graph of the related function will cross the x-axis at 2 points. If b squared minus 4ac is equal to 0, in other words, if you get a 0 underneath the square root sign, then the equation has one real solution, and the graph of the related function touches the x-axis at 1 point. It does not cross it, it actually just touches it. If b squared minus 4ac is less than 0, that is, if you have a negative number underneath the square root sign, then the equation has no real solutions, and the graph of the related function does not cross the x-axis. So let's take a look at a couple examples here. It says state the value of the discriminant for each equation and determine the number of real solutions of the equation. Then solve each quadratic equation by using the quadratic formula. So here we have 3x squared minus 5x minus 10 equals 0. So first thing I want to do is to find the value of the discriminant. And that's b squared minus 4 times a times c. So that's going to give me 25 plus 120. So the value of the discriminant is 145. And since that is a positive number, that means that I'm going to have two real solutions. Okay. Now we need to solve the quadratic equation using the quadratic formula. So that is x equals negative b plus or minus the square root of b squared minus 4ac, but I've already calculated that as the discriminant. So I know that b squared minus 4ac is going to be 145 all over 2 times a. So that's going to give me x equals, that merely means the opposite of negative 5, which is a positive 5, plus or minus the square root of 145. Let's see, if I do a little factor tree on that, that's going to be 5 times 29. So that square root is not, I cannot simplify that. So I'm just going to leave it as the square root of 145 over 6. And that is your solution. Often it's best to leave it in radical form. And realize that that is two answers. That is 5 plus the square root of 145 divided by 6, and 5 minus the square root of 145 divided by 6. Let's take a look at this next example. 2x squared plus 4x plus 9 equals 0. Let's go ahead and calculate the value of the discriminant. So that's going to be b squared, which is going to be 16, minus 4 times a times c, which is going to be 16 minus, what does that come out to be, 72, which is 16 minus 72 gives me a negative 56. And since the value of the discriminant is negative, that means that there are going to be no real solutions to this. So I guess technically I don't have to plug it into the quadratic formula, but because I know there's not going to be any solution, but let's see what that would look like. So x equals negative b plus or minus the square root of b squared minus 4ac, which I figured was to be negative 56 all over 2 times a. So that's what it would look like when I plug it in there, but then realize you can't take the square root of a negative number. So again, there is no real solution. So here are a couple practice problems I'd like you to try on your own. Do the same thing, find the value of the discriminant, use that to determine the number of real solutions, and then solve the equation using the quadratic formula. So if you would stop the video now and try these on your own in your math journal. Okay, let's take a look at these problems. So here I have the quadratic equation 4x squared plus 4x plus 1 equals 0. So I want to find the value of the discriminant, which is b squared minus 4 times a times c, which is going to give me 16 minus 16, and the value of the discriminant is 0. Looking at the notes up above, you'll see that if the value of the discriminant is 0, there is one real solution. And what that means is that the graph of this related function is going to touch the x-axis in only one point. Let's go ahead and use the quadratic formula and find out what that point is. So x equals negative b plus or minus the square root of, I already calculated what b squared minus 4ac is, that's 0, over 2 times a, so 2 times 4 is 8. Simplifying that, that's going to give me negative 4 over 8 because that just goes away. So x is equal to negative 1/2. And indeed I do have one solution, and that's because I was doing plus or minus 0, which doesn't result in anything. And remember, that means that the graph of the related function is going to just touch the x-axis at the point x equals negative 1/2. And let's take a look at our last example here. I have 2x squared minus 3x minus 7. The value of the discriminant is going to be b squared, which is 9, minus 4 times a times c, which is negative 7, or 9 plus 56, or 65. So since my discriminant is a positive number, that means I'm going to have two real solutions. And let's go ahead and figure out what those solutions actually are. So x equals negative b, so negative, the opposite of negative 3 is positive 3, plus or minus the square root of, and I already calculated b squared minus 4ac, that's 65, all over 2a, which is 4. And 65 factors into 5 and 13, so I can't simplify that radical. So this right here is indeed my answer. X is equal to 3 plus or minus the square root of 65 all over 4. And remember again, this is two answers because it's 3 plus the square root of 65 and 3 minus the square root of 65. So in this video, we took a look at how to solve a quadratic equation by using the quadratic formula and using the value of the discriminant, that is b squared minus 4ac, to determine how many real solutions there are to the quadratic equation.